All right, guys, we spent 2 days working on how to work out logs and doing some things with logs, and now we're going to learn how to graph them today. So that's where we're heading. And remember, every time you see the word graphing in a title, you should be thinking, yes, that means it's not going to be too hard and it's not going to be. Um, but before we get going too far on that, tomorrow on Wednesday, we'll do our Google Meets for the first time. There's our times. D period 12:35 on the dot. X period 11:30 on the dot. It's a required meet. We have to do it. So want to see every single one of you there. It'll be an assignment grade. So make sure you show up. Don't be absent. Okay. Graphing, and I'll put that on Google Classroom and send you a reminder to remember. So graphing log functions. Here we go. I need you to remember this fact. Logs and exponential functions are inverses of each other. So what used to be true with the exponential, which we graphed last week, remember they look like this. The graphs kind of did this kind of thing where they went up like that, or sometimes they went down like this. Or if there's a negative in the front, they were down here. And the x says we had asymptotes, had horizontal asymptotes, but guess what? Tomorrow we're going to have, or today we're going to have vertical asymptotes. Everything switches, your x and y switch. Instead of the graphs looking that kind of curve, the graphs are going to kind of do either this kind of curve or sometimes that kind of curve. Okay, so that's what they're going to look like, and they're going to have a vertical asymptote instead of horizontal. It's going to be the y-axis, and this has been shifted sideways. And I'm just going to show you, I think I have 3 or 4 examples right here, and I'm going to go from easy to hard, and the hard ones aren't that bad. And I want you to find 2 points just like we did last week and graph away. So here we go. All right, first one says graph log base, and the base is so important today, base 4 of x. What I want you to do for the first one, first of all, the vertical asymptote, there's no shifting on this one whatsoever, which means the vertical asymptote is going to be the y-axis. So the vertical asymptote, I'm going to try to draw that pretty good. Right there, vertical asymptote. Now we need 2 points. We always put a point. Remember last week we'd always start 1 up of the asymptote. Today we're going to start 1 to the right of the asymptote. And that is true because if I were to plug in 1, which is where I put that point, if I plug in 1 right there, it's basically saying 4 to what power is 1? The answer is 0. 4 to the 0 power is 1. That's why this point works almost all the time. The other point I want you to plug in every time is the same number as the base. So I want you to put a 4 in for the next. So it would look like this, log base 4, 4. Anytime these two numbers are the same, what I'm about to tell you is going to be true. This is asking you 4 to what power is 4? Hello, the first power. It's always going to be 1. Anytime those two numbers are the same, the value of the log is 1. So I'm going to go to 4. I plugged in 4, and I got 1. There's my second point. So all you got to do now is connect the dots, get close to the asymptote. It curves just like this, and there it goes. All right, that's all there is to it. Let's go a little bit tougher. Okay, what if there's a number outside, like log base 3 of x plus 2? Only difference is, notice I don't shift the asymptote up or down, it shifts sideways. So this time there's nothing inside the log to shift it, so the asymptote is still there. Remember our first point, usually I would go 1 to the right here, but I'm still going to, but it's got a plus 2, which means it's been shifted up 2. So there's my first point right there. Now to get my second point, remember I'm always going to plug in whatever the base is. This time the base is 3. So I'm going to plug in 3, which gives me log base 3, 3. That's always 1. And remember, anytime those two numbers are the same, it's 1. 1 plus 2 is 3. So I plugged in 3, and I got 3, which is right there. All you do is connect your dots like we always do, and there's the graph and your 2 points. Be nice if you told me what your 2 points were over here in case your graphs get a little messy, like one of the points was 1, 2, the other one was 3, 3. That way I know exactly where your points were. Got 2 more for you. Okay, what happens if you have a parentheses in the graph and the shift is inside, which means it's going to shift out left to right. This time it says plus 3, so I'm going to shift left 3, right down through here, left 3. It's pretty good asymptote for me. Going to go 1 to the right of there. There's no shift up or down, so I'm going to actually go 1 to the right. So my first point is -2, 0, and that's good. Now, I need that number in there to be a 5. Right now it's x plus 3. So you got to ask yourself, what am I going to put in for x to make that a 5? And the answer is you're going to put a 2 in for x. So I'm going to put a 2 in for x, which makes that parentheses be 5. So now it's really this which means the numbers are the same, which means you always get 1. So I'm going to go to the point 2, 1, way over there, connect them like we always do, just like that, and you got it. All right, one more. All right, this one says log base 2 has everything. It has the x minus 3 and a minus 2 on the outside. So let's talk through the whole deal. First of all, the minus 3 inside shifts your graph left to right, opposite of what you think. So my asymptote is at minus 3, right there. I'm doing pretty good on those. You always go 1 to the right there, but it's been shifted down 2. So I'm going to go down 2. There's my first point. That point right there is at 4, negative 2. I like it. And now I need my parentheses to be 2 because that's what the base is, which means my x is going to be 5. So I'm going to plug in 5 for the x. And if I do that, I get log 2, which is 1, minus 2, which is negative 1. So I'm going to go 5, negative 1 right here. And I'm going to connect those. Just like that. And you know what? I just realized I said there's one more. I'm in the middle of making this video and just figured out there's one kind I forgot to show you. So I'm going to make one more slide and show you that really quick because there's one case you haven't seen. Hang on. Okay, I promise this is the last one. I went ahead and just free-handed everything because I know some of you are having to do that at home, so I might as well show you one like that. I hope you can still read my writing. What makes this different is the base. I haven't shown you one yet with a fraction base. Remember last week we had exponential growth and exponential decay. Same thing's true with logs. You can have log growth, which you've seen already, or you can have log decay. And this one, if there's a fraction less than 1 as your base, your graph is going to go down. So the asymptote's still the same. So my asymptote, there's no shift left or right. So there's my asymptote. That's still my asymptote is the y-axis. Here's the difference. I don't want you to put a 1/2 in for x. Well, before we get there, still going to go 1 to the right, but we're going up 2 because of the plus 2 at the end. So there's my first point right there. So I'm going to go 1, 2. Now before, what I was having you do, I was just having you put the same number in, and technically, you still can. I didn't think I wanted you to do this, but you know what? I think we're good doing that. So still put a 1/2 in there, but I want to show you what happens with the graph. I have log base 1/2, which is 1, plus 2. So I'm putting in 1/2. That's the problem. That's what I kind of didn't want you to have to do. Put 1/2 in there, and if you do that, you're going to get 3. Make sure that makes sense. Log 1/2 is 1, plus a 2 is 3. So I'm going to go 1/2, 3, which is up here. Okay, so the difference in this graph and what you were seeing on those other slides, this is only true when there's a fraction base, is decay, so your curve goes this way. Okay, so it's going down. And you can get that doing the same process. I didn't think I wanted you to do it that way at first, but then once I talked through that out loud to myself, I like it that way. So do it the same way, but expect if you have a fraction base less than 1, your graph's going to decrease. All right? Your assignment will either be, I haven't figured it out yet. It'll be on either Google Docs or it'll be on Delta Math. If I like Delta Math, I'll do that. If I don't, I'll make my own Google Doc and put that on there and turn it in today. See you tomorrow at your appointed time for our Google Meets. Can't wait to see you. It's been a long time. Gosh, it's been a long time. So I'll see you tomorrow, but get your work done today. See ya.